All right, I am making a video during lunchtime, so you might hear some music in the background. Anyway, as I do problem number 15, I'm looking at the fact that I have polynomial over polynomial, but the numerator's degree is not less than the denominator's degree. That means I have to begin this problem through division, polynomial division. And I'm going to do the box division technique. And with that, I am looking at the fact that I am dividing by x cubed minus 2x squared, and if needed, plus 0x plus 0. The next thing I do is I take the numerator leading term, put it in the upper left corner of the box interior, and then I have to figure out what do I multiply x cubed by to get that. That would be 1. And now I need to go down this column, 1 multiplied by negative 2x squared. And then I'm just going to get 0 and 0 with those. Once my divisor is a constant, which it already is right off the bat, that means everything beyond this line to the right of it is within the remainder. I need this numerator to be in the interior of the boxes. So far, I have x cubed, check, minus 2x squared, check, and then I have nothing left after that, but I need minus 4, so minus 4 is going to be my remainder. Technically, I am looking at the constant is found by adding these two, so I can put the minus 4, I should put a negative 4 there. Perhaps you can hear that band. Anyway, remainder is negative 4. That means that this integrand is an entire polynomial result of division 1 plus a remainder, negative 4, that was not able to go through the division process when dividing by x cubed minus 2x squared. So that's the division process. Now, I'm able to integrate this first term. For this second term, I am now back to, I've got a polynomial over a polynomial. I love it when the bands scream, don't you? Anyway, that's painful. The singing, Okay, I'm trying to stay focused on this video. The numerator is less degree than the denominator because it is degree 0, denominator is degree 3. That means that I want to see if I can do fraction decomposition. And because I can factor that denominator, fraction decomposition, here I come. I can factor an x squared, and that leaves me with x minus 2. And what I've got to realize is this is a linear factor that is repeated. And this is a lone linear factor. With my fraction decomposition, when I have a repeated linear factor, that means that I put in that linear factor to its exponent plus that linear factor down one exponent until I reach to the 1 power, which I already did. I have the linear factor x minus 2. Because all of these are linear at their core, I put just an unknown constant above each one. The negative 4 divided by the factored x squared times x minus 2 must be equal to this ABC fraction format. Now, multiply by the denominator. The left side is -4. The right side, A needs to multiply by x minus 2. B needs to multiply by x and x minus 2. And C needs to multiply by x squared. I can, at this point, plug in the zeros of the original denominator. That would be x equals 0 and x equals 2. When I plug in x equals 0, let me scroll a little bit. There we go. When I plug in x equals 0, I get -4 equals -2a plus 0 plus 0. My a is equal to 2. When I plug in x equals 2, I'm getting -4 equals 0 plus 0 plus 4c. My c is equal to -1. I only have one more unknown constant to find, so I'm going to go ahead and plug in another x. When I plug in x equals 1, 1 is chosen because it can be any number that isn't already chosen, and 1 is the best number that's left over. I get -4 equals, and plugging in 1, I have a times -1 plus b times 1 times -1 plus c times 1. I already know a and c, so -4 is equal to -a. I'm just going to change the plus negative to minus b plus c, so -1. And then that is -3, add 3 to the other side, and I get -1 equals -b, so b is equal to 1. Now I'm going back to what I was supposed to integrate. And I am integrating the entire polynomial 1 plus this fraction decomposition of the second term. And now that I know my a, b, and c, I'm going to write down that this is the integral of that 1, the result of the polynomial, plus a over x squared plus b over x plus c over x minus 2, I believe, that denominator. Now, I am solving a definite integral, and it is 3 to 4, so I'm going to put the 3 to 4 on, and I am ready, finally, to go through the integration. So far, we've only done algebra. Now for the calculus part. Integral of 1 with respect to x is x, plus 2 times integral of x to the -2, which is what 1 over x squared is. Add 1 to the exponent and divide by that new exponent, plus integral of 1 over x is natural log of absolute x, minus the integral of 1 over u, where u is x minus 2, will give me natural log of u. Put the x minus 2 back in and realize the derivative of x minus 2 is 1. So I don't have any extra constant multiples due to the u substitution. I don't need my plus c because it's a definite integral. And I'm going to rewrite this a little bit. I have x minus 2 over x plus natural log of absolute x minus natural log of absolute x minus 2. And if I want, I can actually combine those two together. So how about I do that? x minus 2 over x plus natural log of, and when I'm subtracting, I divide the insides, and now evaluated from 3 to 4. Plugging in 4, I get 4 minus 1/2 when I reduce the fraction, plus the natural log of, plug in 4, and I have a 4 divided by 2, so I have natural log of 2. Minus, plug in the 3, I have 3 minus 2/3, plus the natural log of 3 divided by 1, so the natural log of 3. I'm going to add the opposites. And now I can see that for constants, I have 4 minus 1/2 minus 3 plus 2/3. So with the 4 minus 3, I've got a 1. Common denominator is 6. So this will turn into 3/6. This will turn into 4/6. 4 minus 3 is 1. So I end up adding 1/6 to the 1, giving me 7 over 6. Then with my logarithms, I have plus natural log 2 minus natural log 3. Log rules say when I'm subtracting, divide the insides. So I have plus the natural log of 2/3. And that is the final answer. I hope you enjoyed the band in the background, because I did not. Goodbye.